Okay, hello folks. This is Mike Terrace with the Alaska Department of Fish and Game, and I'm going to give a presentation today about fire and wildlife in the boreal forest. So the first thing off is I just want to let you all know that there's a site, the Alaska Interagency Coordinating Center, and this is a BLM site, and if you go there, it's fire.ak.blm.gov. You will see all kinds of updated information during the summertime about all the fire information going on in Alaska. So this is a good resource for you, whether you're an educator or just a person interested in fires going on in the state. So this example, here's just a map of fire information from that site, and on any given day you could click on it and it'll show you all the active fires, even the inactive fires, and a lot of information about those fires. So sometimes without smoke being in the air, people will not even know that there's fires going on. But then you go to this site and you click on it, and lo and behold, there may be 50 fires burning throughout Alaska. A lot of times we don't realize that if there's no smoke, we think there's no fires, but there's usually always fires burning somewhere in the state in the summertime. And here's just an example of one of the sheets that you can get printed out or just look at. That breaks down the fires based on management areas, and then how many fires year to date and the acreage and all that stuff. So this is a really good site and a good resource for students if you are teaching about fire or ecology in Alaska. So right off the bat, we have different perceptions about fire. Fire, it can cause damage to people's property, lives, etc. So a lot of people don't like fire. They think it's bad. And we've had a campaign, one of the most successful campaigns or marketing campaigns, I think, in history is the Smokey Bear campaign. And unfortunately, that campaign was really about human-caused fires. And the way that it works, though, is people just see the information out there and the dramatic portrayals of fire in animals, and it's just a natural assumption to think that fire is really bad for wildlife based on this information. Hopefully we're going to take a closer look at that stuff and let you analyze that on your own. So let's talk about the boreal forest. The boreal forest. What we see out there usually in the boreal forest is, or any area, is usually vegetation. That's the most visible thing. So we characterize ecosystems sometimes by the vegetation. And the boreal forest is predominantly characterized by our tree species. Those tree species are, one of them is spruce. We have both black spruce and white spruce in the boreal forest. We have these triangular shaped toothed leaves. We have birch, that is another dominant species. And we also have quaking aspen, or trembling aspen, that is another dominant species in the boreal forest. So when we look out in the boreal forest, there are other trees and shrubs, of course, and a multitude of plants, but this is mainly the dominant tree species. So the boreal forest, it encompasses a very large part of Alaska, as you can see here, and most of the forested area is the boreal forest in Alaska. A lot of the other stuff gets to be into tundra. And then if it's not the boreal forest, it gets into the coastal forest and then the temperate rainforest. So a little known fact about the boreal forest is that without disturbances to the boreal forest, it would end up looking like this. It would end up ultimately being dominated by spruce. And really, I say that, but how do we know that? And why is that the case? So if we learn a little bit about trees, we realize that spruce trees are what we call shade tolerant. So they can live without direct sunlight for a long period of time, and they will grow very slowly in those conditions until something happens that opens up the canopy and gives them light and other resources for them to grow faster. So you can go out into any forest around here or in your area and you can test this out. And if you live in an aspen or a birch forest, go out there and look. You will have a really hard time finding young aspen and young birch in that forest because those deciduous tree species, the saplings, they need sunlight in order to grow. You will find, however, small spruce trees just waiting underneath there, biding their time, waiting for the conditions to get better for them to grow. So I say that spruce tree would ultimately dominate, but when we look out in the landscape, that's not what we see. We see a whole variety of different tree species in this mosaic pattern of trees and spruce trees, birch trees, aspens, open areas, etc. And the reason that is because of human and natural disturbances that occur in the forest. So some of the natural disturbances that we have in the boreal forest include flooding. All along our river systems, flooding occurs every year. We have ice scouring events where big sheets of ice go down the rivers and they rip off the vegetation. We have avalanches, of course, as well, that pull trees out and disturb the area. And we have a lot of riverbank erosion that's continuously going on in the riparian or river areas. And it causes quite a lot of disturbance along those areas. And we also have things like insects like the spruce bark beetle and the white spruce. And if you go down to South Central anywhere now, you can see large disturbances going on to spruce trees in that forest type down there. But fire, it really is the big one. Fire is the dominant agent of change in the boreal forest, and it has been since the retreat of the glaciers and since the boreal forest developed. Lightning starts about 200 fires per year in Alaska on average. We have more fires than that, of course, because of human-caused fires, but lightning starts a lot of fires every year. And you can go to that fire.alaska site as well, and you can see different types of maps. This map is all the fires from 1956 to 2001. Every one of those red dots here is a fire, and that's a lot of fires, and they're just basically match the extent of the boreal forest pretty well. There's also some other patterns that you can notice here to see how dense the red is along the roadsides. That's because of human-caused fires. And you can also see some patterns if you look real closely. Some of these are also along river areas where, of course, people also travel and start fires. So why is the boreal forest so fire prone? One reason is because we have hot, dry summers. Another reason is we have frequent lightning. And you may not see lightning all the time, but if you go to the lightning strike site on that same fire site, you can see fire strike or lightning strike maps. And this is just an example of one. For a 24-hour period of May 31st to June 1st, there was 6, 7, almost 8,000 lightning strikes going on during that time period. So lightning is a good source of ignition for fires in the boreal forest. Here's another map. Just showing, it's a little bit of a more updated map. This is the last 2 weeks of lightning strikes, and it's incredibly dense. Thousands of lightning strikes occurring in the interior and in the boreal forest. So we also have abundant spruce trees. Like I said, both black and white spruce trees dominate the boreal forest. Particularly black spruce is the ones that are the fire-prone trees. And there's many reasons why they burn so well. One of those is that they have branches that are that grow down right into the duff in the ground layer and into the duff in the vegetative layer on the ground. So these firefighters call these ladder fuels because they allow the fires to climb right up to the top into the canopy of the trees, even if there's a ground fire. Now, if you look at white spruce, they don't have those. They self-prune, so they don't have these ladder fuels like black spruce does. Also, there's a deep moss understory in the black spruce forest, and that understory is full of species that ericaceous or heath species and moss and lichen that are very, very good at burning. And I'll see if this video works right here. This is just on a dry day. This ground fire is creeping along through that moss understory And then when it gets to these ladder fuels, it catches and goes up into the canopy. So the ground in these black spruce forests carries fire very well. Also, the trees have the needles in the trees have a very high resin content, and excuse me, and they have a lot of volatile compounds in them. So that is what firefighters call these trees gasoline on a stick, because when those compounds get heated and they off gas, they become basically explosive, and they burst up in flames when those compounds become gasified. So they're a very volatile tree, and because of that, most of the stands with that, and because of lightning, etc., most stands of black spruce burn before they get to be 100 years old. And another interesting thing about black spruce, just to show you how fire adapted they are, they have what is called semi-serotinous cones, meaning that they have a waxy coating on, not a complete, but a waxy coating on their seed heads and on the cones. And it requires some type of heat event for them to open up. They will open up slowly during over the hot summers, but when a fire or a really high intensity heat event comes through, you can see all the cones balled up on the top here. That's one way to identify black spruce as opposed to white spruce. Black spruce has all the cones at the top of the tree. So when the fire goes through here, thousands and thousands and thousands of the seeds will be dispersed onto the ground. That's their strategy for regrowing, regenerating. So fire is also nature's recycling. Sometimes it does kill entire stands of trees, especially black spruce, as we just discussed. And fire also accumulates, it consumes accumulated organic material and converts it into nutrients in order for new plants to use that rather than being locked up. It's available to new plants that are growing in the area. So let's talk about acreage here. And this is where we start getting into the real important stuff about habitat and how fires affect animals. So when the news and the fire people report fire acres to like how much burned, in 2004 and 2006, we had millions and millions of acres that burned. And they reported one year 6.5 million acres burned. And so my question is, do you believe that? Is that real? Did 6.5 million acres really burn? And if not, why would they say that in the first place? So the answer to that is no. 6.5 million acres did not burn. And this is the really important concept coming up here. And that is because fires do not just sweep across the land and burn everything in their path. They burn and create a mosaic. Some areas burn, some areas are left untouched, some areas burn slightly, some areas burn more severely. So when the fires are reported, only the perimeter of the fire is reported. So if you have a fire that's 1,000 acres, you don't know how many acres in there are burned, really. You need to go look at that because most likely there's going to be a mosaic in there. So you can look across like all these different pictures of fires. You can look out there, and you'll find that fires leave this patchwork of vegetation. And this vegetation mosaic, as we call it, it means a diverse and productive habitat because it creates a lot of edge effect. And edge effect is where two different ecotones or forest types meet each other. And those are usually the most productive areas for wildlife. So you can see in here, in this picture, some of this stuff burnt very severely and got burned all the trees. Some of it burned into some deciduous trees, but then it stopped once it got in here. And there's some trees that are untouched. So there's a big variety of the burn in there. And how a fire burns is like the intensity and the severity of the fire depends on the immediate weather at the time, for one. Also on the topography, because fires burn in different manners, whether they're going uphill, downhill. And also what kind of vegetation is there to begin with. What is burning? Because even in here you can see black spruce burned up on this hillside right here pretty extensively. When the fire got down into the riparian or the riverine area, where there's cottonwoods and there's white spruce and there's a higher humidity, it did not even burn into that forest type along the river. So how often a fire burns depends more on the climate, the type of vegetation that is existing in that area, and the length of time between natural fires in a given area or forest type is called their fire interval. And here's just another picture of black spruce burning all the way up to this ridge line here where it met a deciduous stands, and the fire did not go into that deciduous woodland because it's more higher humidity and those trees don't burn as well. And oftentimes firefighters will create a fire break here because there's already a natural one, and they will use that to their advantage to stop the fires from continuing. And here, without seeing any fire, we can look out. Here's just an example of the Tanana Flats. And if you look out there, you don't see any burns, but you see this pattern of different forest types and different age, like shrubs here, deciduous trees here. And there's a huge variety in here of different stages of growth. And this is basically resulting from fire, and it's a landscape with patches of forest in a continuous flux of varying stages of succession. And we're going to look at succession here in a minute. So what is forest succession? Forest succession is a very important concept. And forest succession, or succession, is the gradual change in plant and animal communities over time after a disturbance. So let's take a closer look at that. After you have a disturbance in the forest, and we'll use fire as an example because it is the predominant one in the boreal forest, things happen. And they happen in a natural and orderly way. And from 0 to 5 years, first green plants begin to grow. Shrubs, then small trees start to dominate as time continues between 5 and 25 years. And as those shrubs and small trees and saplings get older, birch and aspen will start to dominate the forest for the next 25 to 50 years. And if you notice, you can see once these trees get so old and the canopy has good coverage, you're not going to see a lot of those trees growing underneath there. But you will find spruce trees starting to grow up underneath there. And then between 50 and 150 years, those aspen and those birch, that's getting pretty old for them, and they start to die. And when they start to die, those saplings or the small trees that are growing of the spruce then start to grow in earnest, and they take over the forest. And they will continue to take over the forest until there's another disturbance that occurs for 100 years. So here it is, a look at it again, the progression of succession. And it doesn't always happen exactly this way. Like I showed, there's reasons it could happen in other ways. There could be disturbances that occur within here at any point in the succession. But this is just a general model of how that occurs. And new life rises from the ashes. Once a fire goes through, it's not the end of the world, and things just aren't, everything isn't just dead. Many of the burned plants are not even killed. In fact, they are only top killed, and then they start to sprout. They stump sprout or sprout from the roots very vigorously after a fire. How things grow back after the fire depends on a few things. One of them is how severe the fire was. And I don't mean how intense it was, how big the flames, but how severe. How much did it burn down into the organic layer? How much organic matter did it burn off? And did it get down to mineral soil? Or, all these things. What's left on the ground? And also what the previous vegetation type was. Is that going to regrow? Is that going to stump sprout? Or are we going to start from scratch, from seedlings blowing in? All of these different things have an impact on how things grow back. It's not completely predictable because there are variables. What is around there? What's surrounding it? Which way is the wind blowing? What seeds get blown in? Many factors. So a note, I mentioned something about intensity versus severity. Intensity is how hot the fire is, and we often see that on the news with crown fires where there's the wind is blowing and those black spruce trees, the crowns are just burning up, and there's a massive flaming front. That's the intensity of the fire. It can be a very intense fire, but if you go back there later, I've gone to many fires and gone through there where all of the black spruce crowns are burnt up, and you walk along the ground and there's still living moss and duff and thick spongy layers where the fire didn't even burn on the ground. It just ripped through the crowns. Whereas on the other hand, the severity of the fire is the actual ecological effect. And how did it burn? Here's an example right here where a slow burning fire just slowly burned through here, through the ground, but it burned everything almost, and it burned down to the mineral layer. So it burned off a lot of organic material, and that is a more severe effect. And then when that happens, it takes longer for succession to take place, because you could be starting from scratch with the regeneration. So this is what it all comes down to now. Like, what's habitat got to do with all this? And my answer to that is that habitat has everything to do with it. Because we know habitat is where animals get their food, water, shelter, and their space. And every one of our species has its own specific habitat requirements. And those requirements are generally represented by vegetation types. And in fact, some animals require different or multiple stages of succession in the proper arrangement or the proper placement to get all of their needs met. So without the various stages of succession and habitat mosaics, we would have no species diversity out there. If you're a crossbill that needs spruce trees, or a great horned owl that needs older forests to live in, or a moose that needs willows and young aspens, or ruffed grouse, or a lynx, all of these animals have specific requirements, and they can only be met by having this diversity of our forests. And then a note, yes, so just the way that we think about things on a population basis rather than an individual basis. Yes, in a fire, some animals do die in wildfires. Of course they do. But we do not look at it as individual animals dying. We look at it for the long-term habitat retention and development that will keep populations healthy into the future. So habitat diversity definitely equals wildlife diversity, and we need to have habitat diversity to have wildlife diversity. And that is about all I have for that right now. There's a lot more about fire that we're not going to go into at this point, but I hope that was informative. And if you have any questions, we will do our best to answer those. Thank you.